So we've just spent a lot of time learning how to solve an equation when there's just one variable involved, getting that variable by itself. And the problems that you see on this paper right here, or this whiteboard right here, have multiple variables in them. We have x's and y's. Now, when students see these problems, a lot of them freak out and think it's going to be a lot tougher. But the truth is, if you can do the problems we were just doing with a single variable in them, there's no reason whatsoever you can't do these. They work the same way. So, first of all, I want to point out the instructions, or the title is Isolating a Variable. And the instructions say either solve for y or isolate y. Both of those mean the same thing. When you hear the word isolates, a lot of people probably think of isolation. Isolation kind of means that you're all by yourself. You're secluded somewhere and nothing else is around you. When you're asked to solve for y or isolate y, that basically means, like in this first problem here, we're going to take our equation and get this y right here all by itself. So everything else in the formula is going to go over to the other side, and we just want the y left right there. So if you know how to solve a regular equation, again, you should be able to do these problems. You already know the process. If this was like a plain old number right here, we want to take this whole piece and get it out of here. There's a positive 6x sitting there. The way we move away a positive 6x is by subtracting 6x on both sides of my line. Okay, it's just 6x sitting there. You subtract it and it goes away. All that's left over here is 3y, positive 3y. And on this side, 42 and 6x are not like terms. You cannot combine these. Please do not make that a 36x or a 36. You are not allowed to combine them. So you could either write down 42 minus 6x, just like that, or the better way to do it is to put your variable piece first. You'll see why when we get to chapter 2 with y equals mx plus b. Usually we like having the x guy first. So it was minus 6x, so I'm going to put negative 6x. And the 42 is positive, so I'm going to put a plus 42 here. This line right here is the same thing as 42 minus 6x. I just jumbled up the order. Well, we almost have y by itself now. We're almost done. But the thing that's stopping us is this 3 right there, 3 times y. So to get rid of that, I'm going to divide by 3 on both sides. My 3's cancel here. I just get y. And on this side, when you divide a side of an equation by a number, you need to take each term and divide it by that number. So this divided by 3 here, we need to do negative 6x divided by 3. We also need to do positive 42 divided by 3 as well. So both terms have to get divided by 3. Negative 6 divided by 3 is negative 2, so I get a negative 2x for the first one. And positive 42 divided by 3 is a 14. So I'm going to put a plus 14 right there. And now I have y all by itself in my equation. It has been isolated. That is my final answer. So if that made sense, go ahead and try the second one out for yourself. Pause the video, and I'm going to work my way through it right now. Same sort of deal. Got to get this y by itself. There's a negative 5x sitting right there. I'm going to add 5x on both sides to get rid of it. These are going to cancel. So all I have left here is negative 2y. And on this side, these can't combine. It's positive 5x and then plus 30. If this was negative 30 here, I just put minus 30 is the only difference. And I'm going to go ahead and divide both sides by negative 2. So on this side, you just get y. And over here, 5 divided by negative 2 is not a whole number answer. You could do a decimal, but if you remember slope, we'll get into it in chapter 2, rise over run, you want to leave it as a fraction usually. So I'm just going to leave it as negative 5 over 2x. If it could be reduced, I would, but it can't, so I'm just going to leave it like that. My negative was on the bottom, but if you put it up top, it's the same thing, as long as only one of the numbers is negative. So I divided those two. And positive 30 divided by negative 2 is a negative 15. So I'm going to put minus 15 here. And that is my answer. Got 2 more problems I want to go through in this video. More of the same sort of stuff. Same instructions. I want to get y by itself in each of these problems here. Again, if you're feeling up for it, try out pausing the video and try the problem for yourself. See where it takes you. On this problem, there's a couple pieces that I need to get rid of before I can get y by itself. This plus x and this minus 9 are both just kind of sitting there. So one at a time, I'm going to go ahead and I'll add 9 to both sides. Then I just get negative 8y plus x equals 0 plus 9 is positive 9. To get rid of this plus x here, I'm going to subtract x on both sides. Notice the y was written first here. That doesn't change anything. It just, you need to get the y by itself. Some people will still go for this one because it's in the y spot, but you just make sure you're getting y. 9 minus x, nothing I can do with that, so I'm going to write down negative x plus 9 instead, just rewriting the order, flipping it around. These canceled. Negative 8y is all that's left here. So when I divide everything by negative 8s, these cancel. I just get y equals, this is like a negative 1x. Negative 1 divided by negative 8 is not a whole number. I'm just going to make it a positive 1 over 8. The negatives are going to cancel. X. And 9 over 8 is not a whole number either. Positive 9 divided by negative 8, it'll be a negative. You can either leave it as 9 over 8, or you can make it a negative 1.125. So on this problem, at the end here, you can either leave it as negative 9 over 8, or you can turn it to a decimal, negative 1.125. Either one is totally fine. With the number in front of the x, you definitely want to have that fraction for slope. For the y-intercept, which we'll talk about later. Either way is acceptable of writing that. We have one more problem in this video. It looks a little more intense because of the extra variables in here. We have a's, b. We had a bunch of variables running around. But the problem still works the same way. I want to get y by itself. There's an ax sitting out there. I'm going to subtract ax on both sides. These all get canceled. I just get by left over. And on this side, I'm just going to have negative ax plus c. Rewriting it just like the other problems we've done. Well, to get y by itself, we're going to divide by b, and we get y equals negative a over b. There's really nothing you can do with that. Can't really reduce it or anything. It's just negative a over bx plus c over b. So this would be our final equation solved for y.